All right, so day 3 notes. What we're looking at today, just real quick, reiterate, we're looking at functions and their operations, okay? We just went over the homework. Okay, we just went over the homework. We did that CFA. We filled in that form. Now we're going to look at an activity real quick to review what functions are. We're also going to look at the notes right here, and this right here is your homework, okay? So this is your homework right here. All right, just FYI, I have already recorded this as far as videos are concerned. The video that I recorded are number 1, 2, 4, 8, and 16 on your homework, okay? So if we do not get to the homework, which we may not, you have those videos to help you so that you can actually do very, very well on the homework, okay? The notes that we're going to do today should be way more than enough to do very well on the homework, but just in case, I wanted to record those videos as well from the homework example problems. Just to reiterate, right here are all of your quality questions. These are the things that you're going to look at that I will not post up on the board, but you're going to sign into your Google Classroom and ask yourself, basically you should have learned this from that day of notes and whatnot. Okay? Alright, so let's go ahead and go to our notes. So we're going to go to there we go. Alright, so is it a function? So we're going to do these just real quick. This right here, I want to reiterate the fact of what is a function and what is a curve. So a function versus a curve. Now look, you don't have this handout in front of you. So just a reminder, in your notes in the binder, you need to have notebook sheets of paper sometimes because you're going to take notes that I don't necessarily give you to fill out, okay? So please, if you don't already have that, please grab that real quick. Okay, so let's talk about a function versus a curve. A function must pass what? The vertical line test. Thank you. A curve does not have to pass the vertical line test, okay? So, if you can't see it from the back, I have these discrete points. I have these discrete points. And I have these discrete points. Okay? So this one, right here, is it a function or a curve? It's a function because it passes the vertical line test. So this one's good. Is this a function? No, because it fails the vertical line test. How about this? It's a curve. It fails the vertical line test. So we'll say the checks are functions, the x's are curves. How about this one right here? It is a function. This one? Function. Don't be shy, guys. Come on. So it is going to pass the vertical line test. And how about this one? No, not a function. It's a curve of some sort. And finally, this graph. Is it a function? Yeah, it is a function. It passes the vertical line test. All right. So now, let's look at these. These are a little bit different. These are these mapping functions as far as maybe it's a function, maybe it's not. Okay? So, the thing that should stand out to you is the fact that 0 maps, otherwise 0 maps to 2 and 0 maps to 3. You may have learned this already, that 0 mapping to 2 is this point. 0 mapping to 3 is 0, 3. And back in Algebra 1, if you graphed 0, 2, you would put a dot right here. If you graphed 0, 3, you would put a dot right above it. Already, just with those 2 points that we graphed, is it a function? No, because it fails the vertical line test. So, if you need to do these little doodles or whatever, do it. It'll help you easily determine whether it's a function or not. Okay. A misconception right here is 1, 3, and 5. They all map to the same number. Is it a function? Yes, that's allowed. Okay? One x value mapping to 2 is not allowed, but multiple x's going to one y is allowed, because if I were to graph this, I'm graphing 1/6. So let me do that over here. So let me graph 1/6, which is about here, 3/6, which is about here, and then 5/6, which is about here. You see how that passes the vertical line test. So if you see this, this is a function. Now, what I just did with those two examples, I want you to look at this and in your head, graph it in your head if you need to. Tell me, is that going to be a function or a curve? So picture it, -1, -4, 2, 8, 5, 20. Does it pass the vertical line test? Yes. So this is a function. You'll see what we did there? I want you to do the same thing right here. -1, 5, 2, 5, 3, 5, 8, 5. Is it a function? Yes, because if you plotted those points, they're all going to be almost like this was. Okay? So that's a quick review just with what functions are, just to make sure we're good to go before we move on. Any questions? Okay, so now let's go to function notation. All right, function notation, operations and compositions. Okay, function notation is basically f of x, g of x. Operations are you multiplying, are you dividing, are you subtracting, adding, what are you doing? And compositions will look something like a two-step process. Okay, we're going to get to this here in just a bit. Alright, so what you will see today is that you will be able to understand and apply function notation. You'll be able to evaluate function notations with these operations. And also you will be able to work with compositions, which are multi-step processes. Okay? So here we go. It says evaluate. Now we're not going to get into groups, but we're going to do this together because I want to make sure that you know what you're doing. And we may run out of time. Alright. How many functions do you see? Please don't be shy at all. Speak up, please. How many functions do you see that are given to you? Anyone? Two. The first function that's given to us is w of t. Alright? The second function that's given to us is p of t. And just real quick, because at home sometimes it's better that we kind of see things. So we have that. We have another one. And let's say we have something like this. Alright, so I have three appliances in the kitchen. I have a microwave that I could call m of x. I have a refrigerator. Let's call a refrigerator, let's say f of x. And then I also have a stove that I could call, if I wanted to, s of x. Go with me? These all have a function. That means they all have a job. They all do something, okay? They're all built to do something. And we just happen to label them with the first letter of what they are. A stove, a fridge, a microwave, okay? What I want you to understand is you will put something into this refrigerator. That's your X input value. You will put something into the stove and you will put something into the microwave. You with me? What it spits out is the result. It's the Y value. What it spits out is the Y value, and what it spits out is the Y value. You're doing what you did in Algebra 1, just on a different level. Instead of entering X first, which you still are, instead of getting a Y answer, we're just going to call it an f of x answer. It's a result. Do you follow? Okay. Here we go. This machine, think about it like a machine. This machine's job is to take a number, multiply it by 2, and add 5. Any number you give it, it will multiply by 2 and add 5. You with me? P of t's job is to take a number, multiply it by -5, and add 3.2. Those are the operations of those two particular functions. Are we good? All right, so now, what does w of t equal when t is 10? So what you're going to do is you're going to go to identify which function are we talking about first, and we're going to enter the value of 10 for t. So we're going to say the value at 10 on the w function will equal, if I plug in a 10 where I see that input t value, I'll get 2 times 10 is 20. I'll get 25, and therefore w of 10 is equal to 25. Back in Algebra 1, you saw this as xy. Otherwise, in this case, x would be 10, and the result would be 25. The input that we threw into this equation was 10. Okay? And we threw it here and here to say w of 10 is equal to whatever all this is. Okay? And the 25 output value is the answer that we got. It's the result. Think about it. Let's say if we got eggs and we put them in the fridge for 20 minutes. Would the results or the output be different than if you got eggs and you put them in the microwave for 20 minutes? Yeah, they're going to be different because they have different functions. Okay? Any questions before we continue?
So if we wrote the answer, we would write W10, not WT?
Yes, that's a really good question. Don't write W of t. You're going to write W of 10 is equal to 25. You with me? Now, how do you think we should interpret this? That's a really good question that Aaron just asked, because of the fact that a lot of people don't realize that this right here is the same like you did in Algebra 1. Now I'll read it. On the w function, it could be a graph, it could be a table, it could be an actual equation. On the w function, when I input 10, it spits out 25. Think about the Coke machines that are over here near the cafeteria. You with me? This is going to be a big analogy. They accept inputs. Let's concentrate on one Coke machine. Okay? Let's say it has Coca-Cola, Sprite, Dr. Pepper, and tea. Where can I put inputs into that machine? On the coin slot, right? So on the coin slot. So wherever it is, so there's the Coke machine, whatever. Let's say that the coin slot is right there. Okay? And you're putting quarters in there, you're putting nickels, you're putting dimes. This accepting coin slot input value is the same as this input that we're throwing into it. Okay? Now what comes out of it is the dispensing can way down here, or the bottle, whatever it is, right? So there's your bottle. So there's your soda. That's horrible. But anyway, so there's your soda that comes out. Over here, it's going to match with the result that came out from that function. Okay, I overkilled it just a little bit because if you understand it to that level at the very beginning, everything else is fairly easy, okay? All right, so let's keep working. If P of t is 17, so this is a little bit different, then what is t? Here we go. Let's identify what are we working with. We're talking about this machine right here. You with me? So if I said that P of t is 17, I'm saying that the answer is 17. You with me? It's like you're working backwards. You're not putting quarters in the coin slot and getting a soda. You're seeing what soda came out and you're trying to figure out what did you input to get that soda. Okay? Alright, so we're going to put 17 as our answer. We're copying this machine as -5 parentheses plus 3.2. And the reason why we left that parentheses is normally we would throw in an input value, right? But we're trying to solve for t. So if we're trying to solve for t, we are going to put t right here and work backwards. So I have negative 5 times t plus 3.2, and we're going to work backwards to find t. Algebra 1 tells us to do what first? Subtract 3.2. So with a calculator in your head, 17 minus 3.2 would be what?
13.8.
Nice, 13.8. You may have to do the next step with a calculator, and please do if you need to. Right here, we would divide by negative 5. Please don't leave answers like this. Your answers should not ever have a fraction and a decimal. It should either all be decimal or all fraction. Okay? And most of the time, if you press Control Enter, you'll get them in decimal form. Anyone, what's the answer? Nice. Negative 2.7, right? 76. So notice what we did. Don't get into a routine of, okay, I see this, I do this, I see this. No. Think about what you were given and what you're looking for. Here I was given the output. I'm solving backwards to look for the input. The first one I was given the input, and I solved just regular forward to get the output. Now, what is W of A? This is a big question. And it ties in with what Aaron was talking about before. Should you write W of 10? Should you write W of T? Should you write W of A? Alright? So, W tells us we're going to be working with this machine right here. So let's build the machine. We're going to say 2 parentheses plus 5. All I did was write this out, and I put a parentheses somewhere. Guys, sometimes you will see multiple letters here and then all throughout the equation. And Aaron's question was awesome because how do you know where to draw these parentheses? Well, you will know where to draw them because the variables that are going to be to the right, you're going to draw them everywhere where this variable is located. That's where you're going to put these parentheses waiting an input. It's like creating that coin slot on the Coke machine that I was talking about earlier. Okay? You're creating those pieces of where you're going to put an input. What am I throwing in, guys? What am I going to input right here from this question? An A. So not always will you put a number in there. Sometimes you can put letters or equations. Okay? So if I put an A in here and I multiply it out, I would get 2A is equal to 5. That whole thing, all of this, became the answer. It's not a number like negative 2.76. It's not a number like 20. It's an actual equation of 2A plus 5. Questions? Okay, so let's keep going. What is P of x plus 1? So, we need to find our P function, which is right here. Here's the machine. We're going to quickly build the skeleton, if you will. And we're going to throw into our input variable what? X plus 1, the whole thing. From distribution in Algebra 1, we learn if we have a number in front of parentheses like that, we will distribute. So we get, anyone, what? Negative 5x minus 5 plus 3.2. Got to finish that off, right? Whatever's there. Let's combine like terms. What's negative 5 plus 3.2? Negative 1.8, right? So we get negative 5x minus 1.8. And this is the answer. Watch, if we plugged in x plus 1 into the P function. Questions? Okay. Oh. Alright, so we've plugged in numbers, we've plugged in expressions is what they're called, into functions, and we've created outputs, either as functions or as numbers. Numbers create numbers, variables create expressions, okay, or functions if you will. Alright, so there are the answers that we went through and we got together. Now, P of smiley face is just an emphasis of saying, in this equation of P, watch as I highlight, wherever I see a T, that's where my coin slot is going to go over here. Okay? So if you build it, it would look something like this. And what is it that I'm actually going to throw in here? The smiley face. So the answer to this would be -5 times smiley face plus 3.2. Well, it would be P of smiley face is equal to that, and it would all look like that. Okay? You're not inputting P, you're inputting the smiley face.
I was just saying if we need to put the P of smiley face.
Got you. Yes, I like that. That's nice and refined there at the end as a final answer. Yes. Okay? Now, is W of P of 2 the same as P of W of 2? Some of you are probably thinking no already. And I think my example that I gave you earlier might have helped you say that fairly quickly. Think about it like this. Let's say that W is like working out. Okay? And let's say that P is eating pizza. Okay? Now look, I'm introducing something new right now. These are two-step processes. They're called compositions. Not compositions like you create an essay in English, not that. But compositions are composed of two-step processes. For instance, if you look, W of P of 2 says the P of 2 will be done first. Get your answer. And then, whatever you get as an answer, you're going to plug that into W. Okay? This is my example. W of P of 2 says, let's say I were to eat 2 pizzas first. And then I go work out. Okay? Imagine that. You just ate 2 full pizzas and then you went to go work out. Or, what if you did this one? Where you worked out for 2 hours first, and then you went to go eat pizza. Would your body feel different? Yeah, they would be different because you're going to get different answers because order here matters. Okay? Now, a mistake that a lot of people make right off the bat is they think that these are multiplying together. But you're not multiplying W times P times 2. You're not. There's no multiplication whatsoever. Okay? So, what we're going to do, just like what we just got exposed to, a good way to remember this, PEMDAS says, so PEMDAS, right? PEMDAS is, we learn in parentheses, we do that first, and then we work our way out. A good way to remember this, guys, that P is going to be done first, is think about it in parentheses. What are we plugging into P? You tell me, what number are we going to plug into P? 2. So now, let's go find the machine that is P of T, and where the input value is, we're going to plug in 2. What would I get? What would I get if I plug 2 into this? -10 plus 3.2, right? What does that give me? -6.8. So this right here is going to be a -6.8 as an answer to this P of 2. Okay? And as it was asked before, do we write P of 2? Yeah, you could write P of 2 because P of 2 is 6.8. So guess what we're going to plug into W now? Are we going to plug in the original 2? Or possibly the result that we got? We're going to do the result. So we're going to take this -6.8 and we're going to plug it into our W machine where it's waiting for that input. In other words, that coin slot, if you will. Okay? So let's go ahead and write that out. We'll have 2 parentheses plus 5, and we're going to put this as negative 6.8. What's negative 6.8 times 2? Negative 13 point what? 6. And then you're going to add 5. What is that? Negative 8.6. So W of P of 2 ended up becoming at the very end a negative 8.6. It was a two-step process where I grabbed a 2, I plugged it into P. Whatever you got as an output, you ended up throwing it into W as W's input to see what the answer was. And in this case, it's negative 8.6. Quickly, we're going to do the other way around. We're going to do P of W of 2. Okay? So let's now throw into, so just remember that negative 8.6. So now, let's plug in 2 into W. So that's going to be right here. Guys, what would I get if I threw 2 into W? 9. So that 9, guess where we're going to throw that into? We're going to throw it into P, right here on the machine that's waiting an input. So I have a negative 45 plus 3.2. Do you all agree? And then that would give me a negative what? 41.8. Obviously, those two are different, just like you said they would be. Okay? Questions before I keep going? Okay. So, the numbers tend to be easier than whenever we're entering letters. Okay? So check this out. I'm going to enter T inside of W. Well, duh, that's all of this right here. So W of T is this. And I'm going to plug it into P. So all of this will be plugged into our variable that is waiting an input, like when we build the bare bones, if you will. We would plug in all of this here. So you have 2t plus 5. Any questions from what I just did? Okay? Let's distribute. We distribute, we get a negative 10t.
What happened to the W? So like you plugged into 2t plus 5. What was the W?
So all of this is the W of T.
So why would you just put it?
Because right here, whatever we get from W of T
Oh, is equal. Oh, okay.
is nice. That entire output is what we're going to throw into P as an input. Okay? Nice question. And yes, it is a little confusing sometimes because you're used to seeing those numbers. Okay? So now we'll distribute. We'll get negative 10t minus 25, and we still have to add 3.2. This, whatever it is, will equal P of W of T. You with me? Yeah.
So when you're like finish the equation and you're writing like the answer, would you do P of W of T equals the answer, or
Yes.
would you do P of the answer?
You do P of W of T equals the answer. So let's simplify this. Negative 25 plus 3.2 is about what? Negative 21.8. Okay, so just like Emily said, we're going to write it like this and be done with it. Are we good? Alright, and then yes, you could do the same over here with W of P of T. It's going to look different, okay? So let's do that over here. We're going to take all of P of T. Okay, so we're looking at W of P of T this time. Which one are we working with first, guys? P of T. And we're going to take P of T as an answer, and we're going to plug it into what? W. Okay? So here we go. We're going to take P of T as an answer. We create some space. Right here, this is the answer to P of T. And we're going to plug all of this into W, right here. So if I bare bones it, create the skeleton, it would look something like that. Questions? So let's distribute. We have a negative 10t, we have a positive 6.4, and we're still adding that 5. And if I add it together, just like Emily was saying back there, W of P of t will equal a negative 10t plus 11.4 because it's all simplified and put together. Questions? All right. Real quick, can I have someone volunteer just to make sure that we're good to go? How do I read that? Yes?
P of W of T.
Yep, P of W of t. Anyone, how do I read this? W of P of t. Now let me show you something real quick. P of W of t can also be written like this. They mean the same thing. Okay? W is worked with first, and then whatever you get, you're going to plug that into P. You with me? So over here with this notation right here, it's like the one that's closest to the letter, and then you just keep working backwards. If there's more and more and more and more letters, you just keep working backwards. Okay? And the one that would be W of P of t would be the same as W of P of t. Guys, you heard me say it. What word am I saying with this lowercase little o? Of. You're not multiplying, it's just the process of order. Okay? Questions? Okay. Look at this. You can even do P of P. You can even do W of W. In other words, work with the same and keep throwing it into the same function. Okay. Let's do this. What am I going to throw into P right off the bat? 0, right? So let's go to P, and we're going to throw in a 0 right here. Can y'all tell me, what will I get as an answer? 3.2. So 3.2, I'm going to take that and I'm going to plug it back into P. Okay, so I got a 3.2 as an answer. And if I throw it back into P, it's going to look like this. Let's throw that 3.2 that we have as an answer, and let's see what we get from this. So we get negative 16 plus 3.2. You'll get an answer, anyone, what? Negative 12.8, is that correct? Yeah. So negative 12.8 will be what this is equal to because you plugged it into P twice. Do y'all see what I'm talking about? It's the steps and processes and the order that we're going through. Any questions? Okay, so now let's look at these graphs. Okay, so this is a big part of kind of what all is this even talking about. Notice that f of x is in purple and h of x is in red. Now, I want to find h of 0. Okay? And h of 0 is asking on the h function. Think of h like a roller coaster at Six Flags. There's an h roller coaster and there's an f roller coaster. If we get on the h roller coaster, otherwise the h function, and we go to where x is equal to 0. Guys, this is x equals 0 right here, this big old huge line. Where would we land on the function h? At 1. So it's 1. You with me? So it equals 1. Because what this is saying is, on the h function, when x is 0, the y is 1. You see how we're tying this to Algebra 1? Okay, so now with that being said, let's do our next one. We're on the f function. So we're on the purple graph. And we want to know when x is 5. So that means right here. Make sure you jump on the correct right. What would you get? You would get this right here, right? What is that? 2.5. So f of 5. The y value at 5 on the f graph, otherwise the f roller coaster, would spit out a 2.5. Are we good? Okay. So now let's jump back on f, and f is the purple graph. But this is different. I'm not giving you the input value. I'm wanting you to find that by me giving you the output y value. And the y value that I'm giving you is 0. So on f, when y equals 0, that means when y is equal to 0, it's this big old huge horizontal line. Where on the f graph does it hit and touch that line, intersect? At 0. When x is equal to 0. Go with me? Not f of x equals 0. F of x equals 0 is an output value. X equals 0 is an input value. Now let's try h of x is equal to 3. So now, here we go. I gave you the output y value. We find y is equal to 3. And we want to know when on h would I touch that horizontal value of y equals 3. 6, and where else? 1. So we're going to say at x equals 1 and 6. You can do it like this if you want. Either way will be okay. Okay, so again, you can write your answers as x equals 1 comma 6, or you can individually list them if you want. X equals 1, x equals 6, okay? Just please don't put 1, 6. Because that doesn't tell me if it's x, it doesn't tell me if it's y. You need to be very, very clear as far as what it represents. Alright, so let's look at this one. Find the values of x for which h of x equals f of x. In other words, when would h of x and f of x intersect? 6 and, so right here, they intersect here at 6. And where else? Approximate it. Negative 0.5, negative 1/3, whatever it is. Let's say negative 1/2. Because remember, you're talking about x values. Questions? Okay. So this is saying find the values of x when that would happen. What if I asked you, what are the values of y at those specific x values? So this one, yep, this one would be 0.5. So you could say at x is equal to negative 1/2, y is 1/2. And then at x is equal to 6, y is what? 3. Otherwise, what you did in Algebra 1, x and y, and over here, x and y. You're just now learning the function notation of how to show it in Algebra 2. Okay? Alright, so let's move on to the last stuff. Couple more slides and then we're done. This one is asking for, what is f of h of 5? Guys, which ride are we riding first? H. So let's get on h. Okay, so we're on h. We're going to go to 5 and tell me, what do you get if you get on h and you go to 5? What would it spit out? 3.5. So h of 5, listen, h of 5, otherwise the y value on h at x equals 5 is 3.5. You with me? So now the second step is we have to plug in what we got as an input into f. Okay? So let's find f. We're going to find when x is equal to 3.5, which is about here. We will hit f right here. And what did that spit out? 1.5 or 1.75. So let me go back to the original thing like it was said earlier today. We would write f of h of 5 would equal 1.75. And you would box it like that. Okay? Let's do the other way around. The other way is saying h of f of 5. Let's do f of 5 first. Here's 5. Jump on f. What do we have? What is that? 2.5. So f of 5 is 2.5. And we're going to now plug that into our h. Okay, so let's find 2.5 now. So 2.5. We're going to jump on h. And we will hit it where? 1, 2, 3, 4.8, 4.75-ish. We'll go back and we'll say at the very end, h of f of 5 will give us 4.75. And as you can see, like we said earlier, they won't be the same. Because order matters. Okay. This is the last of it, guys. And then I'll show you those videos, okay? A table. Don't let it confuse you. This right here, x-axis, x-axis. This is the y-axis. That's the way you can interpret it if you're really good at graphs. Okay? A table can be a little bit different. Notice what we're being asked. We're being asked, what is w of p of 3? Notice what I just highlighted. I highlighted p of 3. In regular words, what is p of 3 looking for? It's looking for the y value. It's looking for the y value on p when x is what? 3. So let's find p, and when x is 3, what would the y value be? 5. So what I'm really now going to do is, I'm going to go, let me show the work up here. What is w of that 5 that I got? So this 5 that I ended up getting is now my input for the next step. And you'd get 12. So in the very end, we'll rewrite w of p of 3 will equal 12. Because,
I see.
no worries, because we grabbed this 5, we found w, we found 5, and we wanted to find the output value.
So like on our homework where it says f of 3 plus g of 2, would you just add those two answers?
So on the homework, because of the sake of time, please watch the video. They're quick little videos of those 5 questions, and you'll know exactly what to do, okay? All right, let's come over here. This one says 2 times p of w of 3. So what we're going to do is we're going to find w of 3 first. So find the w function. Okay? If I plug in 3, what do I get? 8. Okay? So here's the w function right here. I plugged in 3 and I got 8. So now I have 2 of p of 8. Let's find p of 8. Look up here. What's p of 8? 14. And if I now multiply that with 2, my final answer is 28. So you would put it just like that, and you could box the whole thing. our very last question on this video is W of P of 6. Okay? So W of P of 6. Where do I plug that into? The x value for which function? P. Remember, the one closest to it. So here's P. Let's find the input is 6. And what would I get? 11. And that is what we're going to plug into W. You with me? So if I plug it into W, what do I get? So I only have 3, 4, 5, 6. I don't have an 11. I'd have to go all the way here and have 11. You see what I'm doing? What's this jump? 1, 3, right? What's this jump? 2. There's no pattern there. So you can't show it, right?
So that would just be W.
So no. So if it doesn't show it or you can't find it, I want you to write undefined. It could probably not even be on the graph. You see what I'm saying? Like if I graphed W of T, it would look like this. 3, 8, 4, 9, 5, 12, 6, 14. Is that continuous or discrete? Discrete. Do you see any other points drawn? No, so it could be undefined. All right. I believe, yeah, that is it, guys.